Good morning, students. This is Mr. D. Today I would like to complete one practice problem with you that introduces the impulse momentum theorem. Now, before we complete this problem together, I would like you to do two things. The first thing, I need you to complete the reading of the notes that I summarized for Chapter 9, and the second thing you need to do is complete the Chapter 9 weekly questions. I believe there are 11 questions that summarize the chapter. Now, for this assignment, we have a force acting on a cart. I have provided a graph up here for you. Now, this graph is also drawn on your assignment, and it says that the cart is initially at rest, so its initial velocity is 0 meters per second, and the mass of the cart is 19 kilograms. Now, there are 7 parts to this assignment. So let's begin with number 1. It asks, what is the magnitude of force? So what we're going to do is refer to our graph. So it's titled Force Acting on a 19 kilogram cart. On the y-axis, we have our applied force right here. This is our dependent variable, and along the x-axis we have time in units of seconds. This is our independent variable. So number 1 asks, what is the magnitude of force? Well, let's just read our graph. So at time 0, we have no force applied to the cart, and we have no force until we reach a time of 3 seconds, and we have an instantaneous force applied of 25 newtons right there. So on number 1, magnitude of force equals 25 newtons. And please include your units. Number 2, how long does the force act? So starting right here at 3 seconds, we see that we have an applied force of 25 newtons through a time of 7 seconds. So we're going to use the equation for time interval delta t. This is going to be final time minus our initial time. The final time is 7 seconds, and our initial time is 3 seconds. So we have 7 seconds minus 3 seconds. This is equal to 4 seconds. So the amount of time that the force is applied to the cart is 4 seconds. So let's say delta t equals 4 seconds. Number 3, what does the area under the curve represent? Well, let's take a look at our graph here. We have an applied force over 4 seconds. So our area under the curve to the x-axis right here represents the impulse applied to the cart. So what does the area under the curve represent? Let's say the impulse applied to the cart. Number 4, the algebraic expression for impulse. So impulse is equal to the product of the applied force and the time of the applied force. So we have F delta t. Okay? Number 5, it wants us to calculate the amount of impulse applied to the cart. So by using our equation in number 4, our applied force, you guys have already identified from looking at the graph, we have 25 newtons. We're going to multiply this by our time interval right here, and we calculated that to be 4 seconds. So 25 newtons times 4 seconds is going to be equal to 100 newton seconds. Now, remember from the notes that I wrote for you guys, impulse is always described with units of newton seconds. So on number 6, it wants us to calculate the change in momentum of the cart. Now, we know that the impulse momentum theorem, so the impulse momentum theorem is going to be the applied force multiplied by the time interval this is going to equal the change in momentum of the object. Well, right here we've already calculated the amount of impulse applied to the cart. So we have 100 Newton seconds is equal to the cart's change in momentum. Now, whenever we describe the change in momentum for an object, we do not use units of Newton seconds. We use kilogram meters per second. And you might ask, well, how are we going to get there? Well, let's take a look at our units right here. We have units of Newton seconds. Let's first break down the unit of a Newton. 1 Newton is equal to a kilogram meter per second squared. And we're going to multiply this by units of seconds. And algebraically, we can write this as seconds over 1. So what we're going to do is cancel a unit of seconds. So in my denominator right here, I'm going to get rid of the squared. In my numerator over here, we're also getting rid of the seconds. So what I have is units of kilogram meters per second. So the answer to number 6, the change in momentum of the cart, is equal to 100 kilogram meters per second. Now on number 7, it wants to know what is the final velocity of the cart. Well, right here we know the product of the applied force and the time interval is 100 Newton seconds. Now on the right side of the equal sign here, we have the change in momentum for the cart. Now the change in momentum is equal to the object's final momentum minus the object's initial momentum. Okay, so I'm going to expand this here. This is going to be the mass of the object multiplied by the final velocity of the object minus mass of the object multiplied by the initial velocity of the object. Now the problem initially told us that the cart was at rest, so our initial velocity is equal to 0. So 0 times the mass, well, this right here, that's going to go to 0. So what we have is 100 Newton seconds is equal to the mass of the cart. In the problem, it told us it's 19 kilograms. We're going to multiply this by the final velocity of the cart, which is our unknown. So what we're going to do is divide both sides by 19 kilograms. On the right-hand side of the equal sign, the 19 kilograms will cancel. All right, so I've got 100 divided by 19, so we've got 5 something here. This is going to be 5.263. Now, not only do we have to list our numerical value, we also have to list our unit value, and that's what I want to do here. So let's just focus on our units here. So let's go ahead and break down a unit of Newton one more time. So I have a kilogram meter per second squared, and we're going to multiply this by seconds, and we can write that as seconds over 1. And we're dividing by units of kilograms. And algebraically, we can write this as kilograms over 1. So the seconds are going to cancel one of the seconds. So in my numerator, I have kilogram meters per second, and we're dividing this by units of kilograms over 1. Now what we need to do is remember the algebra rule that says whenever we divide fractions, it's like multiplying by the inverse of the denominator. So what I have is kilogram meters per second times the inverse of the denominator. So our denominator is kilogram over 1. This is going to be 1 over kilogram. You can see that our units of kilograms will cancel, and our unit comes out to be meters per second. And we know that we're doing something correct here because in the metric system, the base unit for velocity is meters per second. So our final velocity of the cart is 5.263 meters per second.